After having talked about the mechanism of enzyme actions in lesson 4, we are now getting into lesson 5, where we will have to talk about the factors that affect the rate of enzyme catalyzed reactions. So, this is important to us because in lesson 4 we talked about mechanisms of enzyme action. We said there were two main types. We had the lock and key hypothesis, which was well explained, and we had the induced fit hypothesis. Now, to talk about factors affecting the rate of enzyme catalyzed activities, you will now understand it very well when we shall be outlining those factors and explaining each, showing how they can carry out changes in some enzyme catalyzed reaction. But then, the fact that enzymes are globular proteins, their three-dimensional shape, especially that of the active site, determines the specificity of an enzyme and how it is affected by other factors such as temperature and pH. In checking the effects of these factors, all other factors should be kept constant, such that an optimum levels wherever possible. So all these factors should be kept constant and at optimum levels wherever possible. So, factors that affect the rate of enzyme reactions. Now, we are not getting into lesson 5 proper. We are not going to look at all these factors. There are so many of them. We shall look at the main factors and we shall look at the other factors. So, the rate of an enzyme reaction is measured by the amount of substrate change. The rate of an enzyme reaction is measured by the amount of substrate change, that is, the amount of product formed in a given period of time. So you can only quantify the rate of an enzyme reaction looking at the amount of substrate change or looking at the amount of product formed. That normally will give you an idea of the rate of an enzyme reaction, and this is done on a particular given period of time. The rate of enzyme catalyzed reaction depends on several factors. So when we look at the amount of product formed or the amount of substrate change, this now depends on some factors, and these factors include temperature, pH, enzyme concentration, and substrate concentration. These are the main factors. These are the main factors that can bring a direct or an indirect effect on enzyme activities. That notwithstanding, some other factors that can affect enzyme activity include, we have inhibitors, we have the surface area, and we have the pressure. There are others that are not mentioned here. In the course of reading textbooks, you come into contact with them. But just know that the main ones are the ones that are mentioned above. That is temperature, pH, enzyme concentration, and substrate concentration. We are now going to take each and look into it and see how they can bring about changes in enzyme activities. So we start with the first one, which is temperature. So we are going to look at temperature at all levels. We look at low temperatures, high temperatures, average temperatures, and see how they can bring changes in enzyme activities. The rate of an enzyme catalyzed reaction increases with temperature up to a maximum point called optimum temperature. So the rate of an enzyme catalyzed reaction increases with the temperature up to a maximum point called the optimum temperature. It therefore means that when an enzyme reaction is taking place, the temperature also increases. As the temperature is increasing, the activity of the enzyme is also increasing until it gets to a point where the reaction is maximum, where most products are formed. And that point at which most products are formed, where the enzyme acts best, is called the optimum temperature. We should not forget to know that enzymes work best at their optimum temperature, and that an increase in temperature affects the rate of enzyme catalyzed activity. An increase in temperature normally affects the rate of enzyme catalyzed reaction in two ways. This is important. The first point is that as the temperature increases, the kinetic energy of the substrate and enzyme molecule increase, thereby causing them to move faster and colliding with one another, resulting to a greater rate of reaction. This is just one of the aspects of the fact that when the temperature is increasing, enzyme catalyzed reaction can be affected in two major ways. And this is the first one. In this particular case, the kinetic energy of the substrate and the enzyme molecule increases, and this now causes the two to move faster, bringing them to collide in order to result to a greater rate of reaction. Remember, we said enzymes are molecules and substrate are also molecules. We should not forget that. The second aspect is that if the temperature is increased above the optimum level, if the temperature is increased above the optimum level, the rate of the reaction decreases despite the increased frequency of collisions. This gradually leads to the denaturation of the enzyme. This gradually leads to the denaturation of the enzyme. This is important. This is very important because we have just said sometime that as the temperature increases, so the enzyme activity also increases. But when the temperature now increases above the optimum level, this will now cause some slow or some reduction in the rate of the enzyme reaction. And irrespective of the increase in the collision of the molecules, the reaction will not move further. The reaction will stop to some point because the enzyme will be denatured. The enzyme will be denatured due to the increase in temperature above to the optimum level or to the optimum temperature. A denatured enzyme has the following features or properties. In other words, how does a denatured enzyme look like? That is just what we are trying to look at here. We all know that when the temperature goes above the optimum temperature or the optimum level, the enzyme is denatured. And when the enzyme is denatured, no further activity can take place. Now, how does the enzyme look like after it has been denatured? In this particular case, the secondary and tertiary structures of the enzyme are destroyed. When the enzyme is denatured, the secondary and tertiary structures of the enzyme are destroyed. The enzyme unfolds. The enzyme unfolds. It means it becomes loose, making it unable to carry out any reaction. The active site is also destroyed. It means that the active site that was in conformity to that of the substrate, it destroys such that the substrate can no longer fit into the active site. The hydrogen bonds and the hydrophobic interactions are broken or changed. So these are the things that a high temperature above the optimum temperature can cause to the shape and structure of an enzyme. So the bonds are broken. These are the bonds that hold the elements together. The hydrophobic interactions are also destroyed, rendering the enzyme worthless, rendering the enzyme destroyed, making it unable to carry out any activity. It is important for us to also understand that at very low temperatures, enzymes become inactive, not denatured. I would like to insist here because many students always get lost here, especially in paper 3 when they are asked to carry out some experiments related to this aspect of the effect of temperature on enzymes. I want all of you to understand that at very low temperatures, mostly below 0 degrees centigrade, enzymes are rendered inactive, not called denatured. Because a denatured enzyme can no longer carry out any reaction. A denatured enzyme is an enzyme that is destroyed, an enzyme that no longer functions. But an inactive enzyme is an enzyme that has just gone dormant, that can only react or that can only become active when put under a conducive temperature. Therefore, inactive enzymes normally regain their activities when the suitable temperature is restored. When the suitable temperature is restored. This is important because students have to understand this, because I said at the beginning that we are going to look at the effect of temperature on three facets: at low temperature, at average temperature, and at very high temperatures. So we have already explained this. At low temperatures, enzymes are rendered inactive. As the temperature increases, the activity of the enzyme also increases until it gets to the optimum temperature where it acts best. Then after this optimum temperature, when the temperature now becomes so high, the enzyme is denatured. Denatured, it means it is destroyed completely, not able to carry out any activity. The increase in reaction rate with a 10 degrees centigrade rise in temperature is called temperature coefficient. That is an increase in the reaction rate with a 10 degrees centigrade rise in temperature is called the temperature coefficient, always written as Q10. If the temperature coefficient labeled as Q10 for an enzyme control reaction is 2, it means that the rate of the reaction doubles with every 10 degrees rise in temperature. This is important for us to understand this, because many students always have problems here, because we just said that the increase in temperature in every 10 degrees centigrade rise is known as the coefficient temperature or the temperature coefficient of an enzyme. And if the coefficient temperature of an enzyme control reaction is 2 after the calculation, it means that the rate of the reaction doubles with every 10 degrees rise in temperature. If it is 3, it means that it triples. If it is 4, that is how it goes in every 10 degrees centigrade rise in temperature. Now, this diagram here gives us an idea of what we have been talking about. How the temperature now can bring some changes in the reaction of an enzyme. So, if you look at this diagram, you look at the temperature, rises above optimal level. It means that rises above the optimum temperature, goes above 40 degrees centigrade. When it goes above 40 degrees centigrade, the enzyme molecules permanently lose their shape. When we say that the enzyme molecules permanently lose their shape, it means that they are denatured. Therefore, what does this mean? The active site now is deformed. If the active site now is deformed, it means that the enzyme is destroyed. Because if the active site is deformed, the substrate can no longer fit into the active site. Therefore, the enzyme and substrate cannot fit together. Therefore, no enzyme substrate complex can be formed. And what happens to the reaction? The reaction slows down and there is no reaction at the end. The reaction slows down to no reaction. That is what this chart is trying to tell us. Now, when you look now at this graph now explains exactly what we have just talked about, the effect of temperature on enzyme activity. Now, this graph now can be split in three sections. You can look at it from maybe 0, there the enzyme is rendered inactive. That is why the graph is at its low level there. As the temperature is increasing from 0 to 10, remember I said the temperature can be rising in 10 degrees centigrade from 0 to 10, 20. That is how the graph now is. The enzyme reaction is increasing. The rate increases as to any other reaction until it gets the optimum temperature, which is 40. At optimum temperature, the graph is at its peak. That is where the enzyme acts best. Now, after the optimum temperature, which is 40 degrees centigrade, the curve or the graph starts dropping and drops right down, showing that the rate falls rapidly after about 40 degrees centigrade. At this point, the enzyme is totally denatured, the active site is deformed, and at this point, no enzyme substrate complex is formed. The reaction slows down to no reaction. Now, this graph also explains everything, just like the one I've just explained, but being more explicit. Still, the rate of reaction with respect to the temperature, the heat energy causes, is that clear? The reaction between the substrate and the enzyme. So you see how the graph is increasing from 0 moving up to 40, and it gets the optimum temperature. For human, it is close to 37 degrees centigrade, as you see there. And above that now, at high temperatures, the rate falls rapidly. That's what you will see in this diagram. The next diagram explains the same thing. All these diagrams are just to explain to you exactly what is taking place. If you look at this diagram now, you see what happens to the enzymes at low temperatures. It is inactive. As the temperature is increasing, it becomes active until it gets to the optimum temperature where it acts best. What happens to the enzyme at high temperature, that is above 40 degrees centigrade? It is denatured. Now, this diagram explains the same thing. And the last diagram now gives you the different sections which you can use in answering any question asked to you. Because I want you to use this last diagram that is labeled, that has a graph that is labeled A, B, C, and D. If you were asked a question on the effects of temperature on enzyme activity, I will suggest that you use this last diagram that has this green graph labeled A, B, C, and D, and section it the way it is here. Because at A, the rate of reaction is very low, and that is where the enzyme is almost inactive. At B, the rate of reaction increases with temperature. You now see that as the temperature increases, the rate of reaction also increases at B. At C, the enzyme is at its optimum temperature. That is, in human, bodies, it will be at 37 degrees centigrade. In some organisms, it will be at 40 degrees centigrade. So don't get confused here. So you now realize that as seen, which is the optimum temperature, the enzyme is at its best activity. Now, immediately after that temperature, that is immediately above the optimum temperature, we are now at D. At D, the enzyme is denatured. The enzyme is denatured. So at that point now, the enzyme can no longer carry out any activity because it is completely disrupted, it is completely destroyed, therefore no reaction, the reaction slows down and no reaction or occurs. All these diagrams, all these graphs are just to explain the effect carried out by the temperature on enzyme catalyzed reaction. I just hope that with all these diagrams, with all these graphs, you will be able now to explain what really happens when temperatures are involved in enzyme catalyzed reactions. Do not forget that it is the Greens Academy that is giving you all these lessons. Thanks for your kind attention.